Hello everybody, so without further ado, let's get started with the first module, which is about Algebra Foundation, the language of math itself. So at the beginning of the point, let's talk about some kind of objectives that we do have inside this part and inside this module, and I would really eager you guys know about it, because as I just told you, algebra is a math that is important for us to know the alphabet at the beginning. So first of all, we are trying to understand the number systems. It would be about the natural one, about the rational, or any other kind of numbers that we do have. After that, we are talking about the absolute value, distance concept. Again, we are going to talk about the PEMDAS, as you just know, maybe. I do have some kind of a complete separate video about this one in the previous part of the channel itself, so don't worry about it if you don't know it right now. I will talk about it in detail, but just in case, you can check that out. And at the end, we are going to talk about a couple of algebraic properties: the commutative, associative, distributive, identity, and inverse. So let's start with this fact that the number system overview. What does that supposed to mean? So as we all know, we do have different kind of numbers. We do have positive numbers, we do have decimal ones, we do have negative numbers, we do have fractions, or we do have some numbers that cannot be categorized inside in any of each of these ones that I just mentioned. It means that each of those numbers that we do have and we are going to use in mathematics or any other kind of science, they're going to be related to one of these categories. So the first one is about the natural numbers. So what are the natural numbers? It means that when you start from 1, 1, 2, 3, 4, and when you go upward, any number, any of these numbers that I just mentioned can be considered as what? As the natural numbers. So as you can see over here in the natural numbers, there is no zero. So it is so important to know about that. For the natural numbers, it would start from 1 to positive, and as you can see, we don't have any decimal numbers, we don't have any fraction, just normal whole numbers. After that, we do have another concept of numbers that, as you can see, rather than just the positive numbers and negative numbers, it also has the zero itself. So this is something that we call as integers. It means that there are whole numbers including negative numbers. So as you can see over here, I do have 1, 2, and to the positive, again, we do have the same structure. We don't have any decimal, we don't have any fraction between them. But I do have 0, and after that I do have negative of this number. So it somehow is going to be there to complete the positive section of the natural number by doing a negative or the opposite number, and also considering the 0 as the number between them. After that, we do have another concept of number that we just call it as a rational number. So what are the rational numbers? Rational numbers that can be expressed as fraction. So what does that supposed to mean? It means that 0.75 or half or -5 or 0 or 6 can be as rational numbers. That's right. As you can see, even natural numbers and integers also can be considered as the rational one. So we can say the rational number has a bigger family rather than integer and natural, that is somehow considered both of those at the same time with something more, and that more is fraction. It means that I can write down the half as fraction. How? 1 over 2, it can be considered as a fraction. What about 0.75? 3 over 4. So I can write it as fraction itself. We do have another concept of number, we call it as irrational numbers. Those numbers that cannot be expressed as fraction. Well, for example, we do have as pi. So what is pi? We all know, we talked about it before. It's a number that we are going to use for the circle, how we can find the circumference and how we can find the area of that one in a specific formula. But just in case, pi is a number or irrational number that it would start from 3.14 and it would just continue to the infinite. So there are so many interesting topics about that. You can just Google it and find it about. But this is a number that cannot be categorized in each of those categories that we have. That's why we call it as irrational number. Another number would be about the root 2. Root 2, just find it in your calculator. As you can see, you do have some kind of limitation, but root 2 actually cannot be considered as any of this one. And we do have the Euler number, which is for the advanced math. And last but not least, we do have real numbers. It means that all of those categories that we had so far are going to be some kind of part of a biggest family of numbers that we know as real number. It means that in the real number, all of the numbers that we have just before, whole numbers, integers, rational, and irrational, considered as real numbers. So let's do a couple of examples to see that do we understand it completely, that which of those category means, and if I do have a number, can I categorize it or not? For instance, I do have -5. So obviously, -5 can be considered as what? As integer numbers. In the meantime, remember, one number can be a member of different categories. For instance, -5 can be integer, can be written down as fraction, so can be a rational number, and also can be a real number, because real number is some kind of the father of all of those numbers. And also we do have half, again, because we can write down as a decimal point, as a fraction, can be considered as a rational numbers. In the meantime, it also can be considered as a real number. We do have the √2, which can be considered as some kind of the real number at the beginning, and also it cannot be written down as fraction. So we do have the irrational number, and we do have the pi, again can be considered as irrational number itself. So after that, we are going to talk a little bit in detail, and by just showing you example about each of those numbers, as we just talked about it. The natural numbers are the numbers that would start from the 1 to positive infinite, and integers are not only they're going to have the natural numbers in themselves, they're going to consider 0 and negative part as well. So we do have the visual representation of numbers that maybe sometimes you would see that it's going to be used in order for add and subtract, or find the distance and absolute values, which we are going to talk about it. But this graphical way is going to help us that how we can show the numbers, for example, +3 on some kind of graphical system, how I can find the -5, and this point is going to help us in order to find the distance between those two values itself. After this part, we do have another section about the rational, irrational, and real numbers. Again, we talked about it in detail. So for instance, I do have a -5, and as I just told you, this table is going to show you that each number can be categorized in different categories. It doesn't necessarily mean that each number only can be divided into one member, it can be considered as one member of only one family. For instance, as I just told you, -5, because it has a negative, obviously is going to be considered as integer. Again, because can be written as fractions, can be considered as a rational one, but it cannot be considered as irrational, because irrational and rational are completely against each other. When one number is considered as rational, it cannot be considered as irrational at the same time. So this can be considered as a real number, and so on and so forth, which we talked about all of. After that, we do have important topic, which is going to be about the opposite and absolute value. So what is opposite? For example, you have +5, and the opposite of that number is -5. So it means that positive are the numbers that they are going to have the same distance on the line number, or on this graphical representation of number, distance from 0, but with opposite sign. It means that when one is positive, another one is negative. In the meantime, we do have another definition about the absolute value, which is a number that is distant from 0 on the number line, regardless of direction. So let's look at the examples. The first one is that about 7 and -7. Obviously, we know that these two numbers are completely opposite. But when we are talking about distance, actually we care about the distance of that specific number to what? To 0. For instance, let's look at this representation. So I do have -7. So what is the distance of this guy to 0, or to some kind of the source part, or the reference? It's just the 7. We are not going to consider the negative value right now and say that, okay, -7 to 0 is -7. No, distance or absolute value all the time is going to be considered as positive. And after that, I do have 7 on the other side. So if I just consider this line as well, I do have the 7. So again, the absolute value or the distance is going to be considered as the distance of that specific number from 0 itself. We do have another definition that we call it as a distance on a line. As I just told you, we are going to use this line, the number line, as a graphical representation to do something. And the most important thing that we are going to do, find the distance of to a specific number, positive, negative, 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 or negative, positive, whatever number that you have in your mind. So when we're talking about the distance is actually going to show itself with this one. Two parallel line, and you're going to subtract those two numbers by itself. So these two parallel lines are going to be say that that number is absolute. It doesn't matter what you have. If you have a negative or positive number in your subtraction, all the time that number is going to be as positive. Absolute of negative 5 is 5. Absolute of 5 is 5. So it means that any number which goes inside the absolute, the output is going to be negative. For instance, I do have 2 points. One is 5 and another one is negative 3, and I would like to find the distance between those two. So obviously by looking at this line representation, you can easily say that, okay, I do have 5 over here and I do have 3 over here, so the distance would be 8. Another easy way to find that one is that you can subtract one number from another. And again, it doesn't matter what number from what number. 5 subtracted by negative 3 or negative 3 subtracted by 5. By both of those situations, you are going to either have 8 or negative 8. But since we are talking about absolute value, the output number is going to be positive all the time. So this is the place that we are going to use this graphical representation and how we can find the distance on the line and try to memorize that formula. It is useful. Another thing that we're going to talk about, which is very important, is the order of operation, or PEMDAS. So it means that each of those operations that you have inside your equation or algebraic expression, or maybe just a normal just putting down some numbers side by side and putting some arithmetic operation beside them, they have some orders. It means that you cannot do whatever you want. You have to follow some orders. The P is representing as parentheses. As we can see over here, I do have this guy as parentheses itself. The E represents as exponents, whatever number, as we know, this some kind of the package itself or the number on the top is considered as a power, or the whole thing is going to be considered as a power, but that teeny number on the top is going to be considered as exponents. What is the definition of exponents? It means that how many times one number or one some kind of unique number is going to be multiplied by itself. After that one, we do have the multiplication and division and addition and subtraction, which is a very important some kind of fact about this one, or I have to say it's a myth, that when we do have the PEMDAS, again, PEMDAS is the very first letter of each of those operations. So when we do have this one, since we do have multiplication before division, if we do see multiplication and division side by side, we have to do the multiplication and after that division. No, it's completely wrong. It means that in multiplication and division, they do have the same order. That's why we do have both of them side by side. Addition and subtraction have the same order. So how we can distinguish which one of those operations should come first? So we are going to move from left to right. So imagine that I do have a case that multiplication and division are going to be side by side. If I move from left to right, and if I see the multiplication as the first operation, I'm going to do that, and after that the division. So just have it in your mind. It doesn't matter M and D come, so M comes first and after that D, or abstract comes first and after that subtract. Both of them should have the same order, but you have to move from left to right. So let's see an example over here, just some kind of common mistakes about this PEMDAS and how we can use it in order to get rid of that. So the first one is that wrong method number 1. It means that I do have 3 subtracted by 2 to the power 3. So I'm going to do that. Sometimes it would happen, since you see the power, it is very common mistake, is that some students are going to get confused that since I do have 3 subtracted by 2 to the power 3, actually 3 is going to be considered for this 2, or it's also considered as this one as well. So they are going to say that, okay, I'm going to do something like this, and they are going to find the wrong number. Remember, if the question asks you that a specific exponent is for both of two numbers, it has to specify using the parentheses. Since this is a specific question, you don't have any parentheses, the power of 3 is only going to be considered as 2. The next some kind of very common mistake is that they're going to say that, okay, 2 to the power 3, actually it's going to be a little bit funny, because 2 to the power 3 means that 2 times 2 times 2. So sometimes they're going to get confused with 2 multiplied by 3, because they're somehow the same, but with the fact that there is going to be multiplication between them. 2 multiplied by 3 means that you're going to add 2 by itself 3 times. 2 to the power 3 means that you're going to multiply 2 by itself 3 times. So at this point, they're going to say that, okay, 2 times 3, 2 to the power 3, potato, tomato. They're the same, right? So they're going to do that, and again, wrong. And for the last one, they're going to do the addition instead of the subtraction. Believe me, sometimes it happens. It doesn't have anything to do with the PEMDAS itself, but you have to be careful all the time when you solve your question. That's why all the time I'm telling my students, try to double check your answers, not just doing it by the way it is, because sometimes you have some faults. And at the end, the right way, which means that we are going to do some kind of find the exponent first, and after that 3 subtracted by that one, and it's going to give you the right number itself. After that, we are going to talk about some algebraic properties or some rules and some laws that we are going to use them in the very future, not right now. So the very first thing that you have to know is about the commutative property. So what does that mean? It means that whenever you have two numbers and you're trying to add them to each other, for example, A and B, you can change their position. It means that it doesn't matter it is A comes first or B comes first. Both of the time the answer should be the same. Look at this point. So I do have A plus B, and is A plus B is 3 plus 5. Does it matter if I say that 5 plus 3? So obviously not. So this is the first rule, and very, very obvious rule that we know about that. And we call it as commutative property. It means that I can write down A plus B as B plus B. Another rule that we do have is about associative property. It means that if I do have the condition like this, A plus B inside the parentheses plus C without any parentheses, I can write it down like this. So again, it's very, very obvious, because addition, and the good thing about addition is that you can use it wherever you like. So this is not going to be right about the subtraction, and also about the division. Sometimes multiplication has some exceptions, but about addition, you have more free hand. So at this point, if I do have 2 plus 3 plus 4, I can write it down like this. It doesn't matter, both of the time the answer would be right itself. As I just told you, the multiplication also do have the same rule. It means that if I do have A times B times C, I can write it down A times B times C. So I can move this parenthesis from here to here. So I do have this freedom with myself. Another rule that we do have is about distributive property. What does that mean? Imagine that you do have this question, A by B plus C. By the way, whenever you see that there's nothing between the parentheses and a number, most of the time it means that multiplication. Just in case, make sure that you know about that, because sometimes they would say that, for example, there's another thing between them, but 99% of the time it's about multiplication. But they're going to get rid of that for some kind of having more space. So I do have this one, means that A multiplied by B plus C. So I can do something in order to get rid of parentheses. How? This one is actually A multiplied by B, A multiplied by C, so I can write it down like this. In the future, we are going to talk about factorizations. It means that I can find a way in order to move from right side to the left side. So right now, we are only talking about left to right. It means that we are talking about distributive property. We're not going to about the factorization right now. Don't worry about it. But this is a rule that we have. So imagine that you have 5 times 2 plus 3. So I can write it down as 5 times 2 plus 5 times 3. So imagine that instead of some addition, I had subtraction. What would happen? Again, same, but instead of just having addition, I do have the subtraction itself. Another rule that we do have is about identity property. It means that adding 0 or multiplying by 1 leaves the value unchanged. So for instance, I do have a number I just consider as A. What is the specific number that if I add it with A, I still do have A? That's right, it's 0. And what is that specific number? If I multiply it by A, I do still have A, that number would be 1. So this is, again, there are some kind of facts that we already know, but they're going to make it fancy. That's why you do have some names for them. And another one would be about inverse property. It means that every number has an opposite. We know about the opposite. When we are talking about two numbers, they're opposite. It means that their distance to 0 is the same, but in different side. One is in positive side, another one is in negative side. So every number has an opposite and reciprocal that yield identity elements. What does that mean? It means that all the time you can find one number that either is going to make your number 0 by adding to your number, or you can find another number that's going to be multiplied by your number and give you 1. So at this point, I do have A sub to plus negative A. So as we all know, this positive multiplied by negative is going to give you negative. So A subtracted by A is going to be 0. and a times 1 over a is going to be 1 itself. As simple as that. That was the whole module that we talked about. That one, again, around 20 minutes. Try to pause the video, try to look at some of those examples and to completely understand, try to memorize the names, which somehow I'm against that, but again, probably you're going to need it, especially in your textbook or in your exam when they ask a specific question. To do that one, you have to be familiar with it. So right now we do have this module. This module is in, as I just promised you, we are going to have some kind of sub module, which we are going to solve different kind of question in around 20 minutes to completely make sure you understand everything in detail. This is Mahmoud Kiasari. Have yourself a great day, good night, whatever. See you around.